Hi everyone. In this video we are going to learn about minerals. So, in geology we study rocks all the time, um, and there will be some videos as well discussing about rocks later on. But for this video we are going to focus on minerals. Basically minerals, if you have a bunch of minerals, if you have a single or multiple types of minerals, you can actually combine them and then you can actually create rocks. Okay. But minerals themselves, they actually are made of chemical elements. Okay, so for example, we have silicon right here and then oxygen right here. Now these are the atomic structures of silicon and oxygen. Now if silicon and oxygens are combined, they're going to make a type of mineral which is called the silicate minerals, or in this case the example would be quartz. Okay, so this is an example of quartz, which is made of, again, those two elements, silicon and oxygen. Okay, and then if you combine quartz with something else, with some other minerals, then it would create something that we call as a rock, or in this case a silicate rock named granite. This is the composition of the whole Earth versus the Earth's crust. Remember that the Earth's crust is the most, or the outermost part of the Earth, and this is something that we already discussed in the previous video. Okay, so I just want to let you know, or I just want you to see the contrast between the composition of the whole Earth versus the crust. For the whole Earth, iron and oxygen will be the two most abundant elements within the entire Earth. Okay, so iron and oxygen and not O2. I'm sorry. So iron and just oxygen. Okay, these are the two most abundant elements within the entire Earth. And remember that iron is mostly found within the core of the Earth. Okay, this is something, again, we already talked about when we learn about the geosphere within the Earth system lecture. Okay. Now, in contrast, within the crust of the Earth, which only represents like the thin part of the outermost part of the Earth, it turns out that the most abundant elements within the crust is oxygen, which is about 46.3%, and then we have silicon. So oxygen and silicon would be the two most abundant elements within the Earth's crust. So this is something that you might need to, understand or remember. Okay, so let's talk about mineral. Um, this is the definition of a mineral, and I rarely give some definitions, but I think it's a lot easier if I can subdivide the mineral definition into 6 different parts. Basically, in order for something to be called a mineral, that particular object needs to satisfy all these 6 conditions. Okay, so a mineral must be solid, and it also must be inorganic, naturally occurring, homogeneous, has a crystalline structure, as well as a definable chemical composition. So these are the 6 main criteria for something to be called a mineral. So let's talk about each of those criteria one by one. So the first criteria would be, or the first character here, a mineral must be solid. Okay, as you can see here, all of these minerals are solid materials. Okay, so we have quartz, turquoise, and one of my favorite mineral, which is called barite. Okay, well, notice that it has my name on it, but anyway, these minerals are all solid. Okay, how about this one right here? This is water, and water is in a liquid phase, is a liquid phase of H2O. And water, because this is not solid, so therefore it is not a mineral. But what about ice? Okay, ice can be a mineral when forms naturally. So for example, here is the ocean. Of course, the ocean itself is not a mineral because it is liquid. Okay, so it is not a mineral. But how about this iceberg right here that we have on the left side of your screen? This this iceberg is basically a solid H2O. Okay, so therefore, and we know that this iceberg forms naturally, so therefore it can be considered as minerals. However, ice cubes within your freezer, they may not be uh, minerals, because of course a mineral must be formed naturally. Okay, because all these ice cubes, perhaps you're the ones, or your family members or your friends who made it, so therefore they cannot be considered as mineral. Okay, the second character is that a mineral must be inorganic. So what does that mean? Okay, that means that a mineral cannot have any trace of organic material. Okay, so for example, this is a picture of coal. And don't get me wrong, coal is such an important deposit in geology, and there's a lot of things that we use with coal in terms of analyzing, the geology of an area, something like that. But coal, it plays such an important role in geology. However, it is not a mineral. Okay, the reason for that is because this is something we're going to learn about, when we talk about energy resources. But coal is generated from organic material. Okay, it has traces of land plants, basically. Okay, so they are organic materials, so therefore they are not considered as a mineral. The next example that I would like to show you is these pearls right here. Okay, if you think about it, a pearl is actually a solid material, and it forms naturally, right? However, pearls are formed by the actions of living organisms. Okay, so these clam right here plays such an important role. It actually is this clam right here is actually the one that produces this pearl. So therefore, there are traces of organic materials within pearls, and then these living organisms contribute in creating pearls. Therefore, pearls cannot be considered as minerals because it is an organic material. Okay. So the next character is that a mineral must occur naturally, and they cannot be formed in the lab. Okay, so for example, these are pictures of diamond, and these diamonds are kind of embedded within their matrix, which are called kimberlite matrix, which is very common in some areas, for example, in some parts of Africa, for example. All right, so you can see that they are solid and they occur naturally. Okay, so therefore, they are so therefore diamonds are minerals. Okay, however, if you think about it, there are also man-made diamonds. Okay, if you go to NYC, there are a lot of jewelry stores over there that they actually have their own labs within their store. Okay, and they can actually grow diamonds within their lab. Okay, so if they are formed in a lab like this, and there's a contribution from humans that created these diamonds, they cannot be considered as a mineral. Okay, so man-made diamonds are not minerals, but the ones that occur naturally, they are minerals. Okay. All right, the next one is that a mineral must be homogeneous. So what do we mean by homogeneous? What we mean by homogeneous is that all minerals will maintain the same structure and chemistry regardless of how small they are. So for example, here I have a cube of halite. Now, if you don't know what halite is, it's actually something that you eat every day. Okay, so this is salt, table salt, okay, that we consume every single day, right? So this is a nice big crystal of halite. Okay, as you can see here, it looks like it actually produces a cubic structure like this. Okay, now homogeneous means that if you break this halite into smaller pieces like this, no matter what size they are, they're going to create the same cubic crystalline structure, which is in this case is looks like cubes. Now, even if it's present in a much smaller size, for example, here are in the center picture right here in the middle, you can see that these little halite or little salt right here, they actually have some cubic structure. Okay, little cubes right here. Okay, look at that. Okay, so again, no matter what size they are, they will maintain the same structure and chemistry, and the chemistry would be sodium chloride, okay, for halite. This is another example of a homogeneous mineral. This mineral is called selenite. Okay, and this picture right here is from Mexico. As you can see here, there's a person standing right there. You can see that that selenite crystal is so big. Look at that. It's very, very tall. And if you notice that this crystalline structure of selenite is actually tabular. Okay, it is very long. Okay, look at that, and tabular. Okay, so no matter what size they are, now this one is the big version of selenite, but this picture right here on the bottom left is also a selenite, but as you can see here, even though it's very small, again, it still maintains its crystalline structure. Okay, so again, this is a good example of homogeneous mineral. Again, it will maintain the same structure and chemistry regardless of how small or how big these minerals are. Okay, the next characteristic is that a mineral must have a crystalline structure. Okay, crystalline substance is an internal structure framework of atoms or ions arranged in a regular geometric pattern. Okay, so you cannot see it here, but quartz consists of silicon and oxygen. Okay, so quartz consists of silicon and oxygen, and then of course our eyes will not be able to see those silicon, these atoms of silicon and oxygen, but we can see the minerals. Okay, but in microscopic view, we can actually view the structure of silicon and oxygen. Okay, so let's take a look at the structure of quartz, for example. So this is the structure of quartz. Okay, as you can see here, it actually consists of this purple ball and red balls right here, and all of these purple and red balls within quartz, they have been arranged nicely, and it actually has a very nice geometric pattern, okay, within quartz. Okay, so quartz is solid, okay, we know that, and it occurs naturally, and it is inorganic, and it is composed of silicon and oxygen. Okay, so quartz are minerals. Okay, however, there's also another type of material which is solid, and it occurs naturally, and it is inorganic, and it is also composed of silicon and oxygen. Okay, obsidian, that's what its name is. Okay, but obsidian does not have an orderly arrangement of atoms like quartz. So let's take a look at what we have within obsidian. So this is an example of obsidian right there. Okay, obsidian also has this purple ball right here, which represents silicon, as well as red ball, which represents oxygen. So we have the same exact composition with quartz. Okay. However, if you take a look at the arrangement of atoms within obsidians, actually they just look very random. Okay, we have silicon right here, we have this silicon right here. um, you know it, it just doesn't produce a nice geometric pattern that we see within quartz. Okay, in fact, these pattern that you see here within obsidian, it actually represents kind of like a liquid material. So that's the unique part about obsidian, actually, because obsidian has a geometric pattern of atoms that looks like liquid, but in fact it's actually solid. Okay, so obsidian looks something like this, and it doesn't have an orderly arrangement of atoms, so therefore it is considered as non-mineral material. Okay, and quartz is good. Okay, quartz is a mineral. Okay. By the way, obsidian is actually natural glass. Okay, natural glass or amorphous. So again, obsidian is not a mineral, but quartz are minerals. Okay, the next characteristics is that a mineral must have a definable chemical composition. It means that every single minerals have a fixed ratio of elements. So for example, all right, I'm not gonna go through mimetite. Aragonite, let's go with aragonite. Aragonite have 1 calcium and then 1 carbon and 3 oxygen. Okay, calcium carbonate, that's what it is. Okay, so if you break this aragonite into two, okay, these pieces right here and that pieces right there will have the same fixed ratio of elements. And again, no matter how small you divide these minerals, it will have the same ratio of elements. And that's the same thing with quartz, as well as my favorite mineral, which is barite. Okay, so these is a characteristic of a mineral, and it would be very different with rocks, for example. So rocks do not have definable chemical composition. This part of the rocks may have slightly different composition from that part of the rock. Okay, so therefore, of course, rocks is not a mineral. Okay. So I think that's what I would like to say in this video, and we're going to continue the next discussion on the next video, and I will see you over there. All right, bye bye now.